I'm sorry guys, there was a small internet disconnections. So we are back, I guess. So let me just check up to where I have explained. So yes guys, there is one very famous mathematical identity called Freshman's Dream, which says that x plus y plus z to the power of 2k is equal to x power 2k plus y power 2k plus z power 2k, which means that if we apply the exact operation 2k times mathematically, 2k times is, what does this meaning guys? This means that applying this operation exactly 2k times is mathematically identical to applying it once but using the neighbors that are spaced 2k times away. 2 power k, I mean 2k times. So this condition is gonna become a of I minus 2 power k XOR iOS. Let's leave my code forces rating as of now, please. I request you. So yeah, this is gonna be a of I minus 2k XOR a of I XOR a of I plus 2 power k, and thus all this drama is gonna be equal to a big Aryabhata's invention 0. I mean Indian invention to math, one of the greatest discoveries of 0. Now quickly moving on to our approach. I'm gonna go fast, I guess the stream is getting dragged. Approach. So break this array into smaller cyclic arrays. Break 2. Why are we doing this? We are doing it because we only care about elements, because we care about elements spaced 2k apart, 2 power k, 2 power k apart. Okay, so now what I'm gonna do is apart. My first step is the number of independent cycles, that is gonna be, we'll take it as m. It is gonna be the greatest common divisor of n comma 2 power k. That's all. And then the length of each cycle. The second step is length of each independent cycle, that is L is equal to n by m. Now 2 steps done. In my third step, in each cycle, what I'll do is, the rule is just x of j minus 1 XOR x of j XOR x of j plus 1 is equal to, all this is equal to the biggest invention, that is 0. Now in my next step, what I'll do is, okay, sorry, wait, let me just tell you one more point. So here what is it happening? This is repeating a sequence of length 3, a recurring sequence, repeating a sequence of, or I'll just write it as repeating sequence of 3, of 3. That is, for example, if I take a comma b comma a XOR b comma a comma b, like this. Now my next step, the fourth step, there's nothing like the problem is out of your level, Akshay. It's just on a good day anyone can solve anything. On a bad day, even tourist is out of top 30. You can see the recent, I guess the spectral round 2, I think, or the round 1, tourist was not even in top 25 or top 30, which is very rare. Even tourists can have a bad day. So yes, the fourth point, and I'm seeing the chat regularly. Now for each cycle, what I'll do is, of length L, you know, right? L must be multiple of 3. 3 multiple. Shall write multiple of 3. Multiple of 3. So what is this gonna give me? If L mod 3 equal to 0, we can say that we can freely choose first two elements of each cycle. For m cycles, that is, that's 4 power m combinations per bit, and across k bits, what will it be? Per bit it's 4 power m, so basic math, 2 into 2 power m to the whole power k, which is gonna give me 2 power 2 mk. And then our second condition, if L mod 3 not equal to 0, the only sequences that works and wraps around, what is it, is all zeros. So in this case, so only one way. That's all, man. Simple. I mean, I simplified it as per how much it's possible. I tried my best to simplify it as per how much it was possible. Time complexity is gonna be O of 1 per test case, because bitwise operations only, and then the space complexity is also O of 1. This is per test case. So it will be O of 1 into t test cases, O of t. Why the time complexity is O of 1 per test case? It's because we are using directly bitwise operators, that is n and n minus 1, and we'll find the greatest power of 2, which we are doing by dividing n instantly, which is meaning that we are bypassing the heavy looping and all that. We are bypassing it completely. With this, we are done with this question. So is that clear, chat? Is the question clear? Any doubts? I'll show you guys the code. Here you go with the code. One of the shortest codes, direct bitwise operations. Here is the condition I said, n and minus n, and then bitwise 1 bit, and then you'll just calculate. No looping, zero looping, basically, literally. The only loop is for what? The input taking. And then you have the mod value here, and you'll just put it for mod value here. That's good. One final question of the day. I have to wind it up quickly. Alright, the sum of subarrays again. Just a second, guys. Okay. So the sum of subarrays again. For an array A where A of I is not equal to 0, we define function of A as max of fi of A for 0 is lesser than or equal to I lesser than or equal to n, where fi of A is computed as follows. F0 of A is equal to sigma j, j is equal to 1 to n A of j. If ai is greater than 0, fi of A is equal to sigma I is equal to 1, sorry, j is equal to 1 to I is equal to 1, modulus of aj minus A of I plus sigma j is equal to I plus 1 to n A of j. And if A of I is lesser than 0, f of I is equal to fi of A is equal to minus 10 power 18. If you think these functions are strange, you can note f of A is as the answer as in the maximum possible sum to your problem Codechef 2229C2. I don't know, I don't care about that question. You are given with an array A to n, array A of n integers. Find the following sum. Sigma L is equal to 1 to n, r is equal to 1 to n, f of a of l plus 1 to a of r. Input format: the input will contain single integer t denoting the number of test cases. For each case consists of multiple input. The first line is contains one integer n, second line contains e of 1 to a of n. Output: new line, the sum of f over all subarrays of a. Constraints: t is in between 1 to 10 power 4, n is in between 2 to 2 into 10 power 5, and the modulus of a of I, like a of I, is in between 1 to 5000. The sum of n over all test cases does not exceed 2 into 10 power 5, but still we need to optimize heavily. But I feel the previous question, not the XOR, but the one I explained previous to XOR, was a bit difficult than this, to be honest. But this was a lengthy code. I remember coding, like, it was just half an hour ago basically. So I still remember it. No pause, I'm gonna explain you guys quickly. What is the title? Sum of subarrays again. The last question, 7th question of again. Yeah, sure. The function f of a. What is my intuition here? The function f of a calculates the maximum possible sum following a strict set of rules, where skipping negative numbers essentially zeroes out the sum, but picking them drops it massively. This evaluates. What does this evaluate here? Imagine the function f of a. What is it doing? Calculate max sum. Max possible sum. Was too fast, I'm sorry for that. With a set of rules. Where which is skip negative zeros the result, and then pick negative will drop the result. So what we need to do is find the maximum prefix sum for this modified array basically. Find max prefix sum for this modified array. Modified version of array or modified array, whatever you call it. Now, to find the sum of function over all subarrays efficiently, we have to simulate it. Very basic, the place where this is gonna fail. O of n square times. Can we afford O of n square in a 10 power 5 solution? No, we cannot. So this is gonna fail. Now I need to batch it. What is my approach? Just let me know the data structure, chat, quick. One of the data structures we use in the last second question of day before yesterday's repo view, we are gonna use a monotonic stack. So what I'll do is, first step, we map array elements to penalty or reward, penalty or values based on positive or negative. What is this gonna do? This will create array of prefix adjustment, array of prefix adjustment. Now quickly what I'm gonna do is, in the second step, I'll sweep right to left, right to left, maintain monotonic decreasing stack, monotonically decreasing stack. So what is this gonna do? This stack is storing the effective values that are representing max achievable sums at various rate points. So by keeping monotonic, what we are doing is, we are grouping together right endpoints. Are you guys clear? We are grouping the right endpoints that is sharing same max prefix value, same max prefix value. Clear? Once we are done with this, third point. Now what we'll do is, we'll we'll take a fixed starting point and we'll call it L. We need to know how many right endpoints are there. We need to know how many right endpoints. That is R will be dominated by current setting or current start prefix sum. And how many exceed it. Now finally our fourth one, the final point, monotonic stack sorted already because monotonic. What I'll do here is I'll use binary search over this stack. So what this does is it like immediately it will split the array into two parts, like two subarrays, or the subarrays into two groups. Subarrays into group 1, group 2, and then here what is group 1 will be where stacks mac or recorded max apply, and our group 2 will be where current prefix sum applies, prefix overrides them. Is that clear? And finally what we will do in this step is multiply by counts and add them. This will give me the sum for all valid hours in log time. Logarithmic time complexity or logarithmic time. Now I'll explain it with the maths, okay? Or I'll just explain you guys with a math how my solution is working, and with that before that I'll give you guys the time complexity. Time complexity, simple, monotonic stack O of n, right? Or you can take the right sweep as O of n, right to left sweep. It's taking O of n, binary search, O of O of log n. So the total time complexity is equal to O of n log n, and our space complexity is O of n for monotonic stack. I'll give you one simple math example for this. Take a very small subarray, e.g. through math. For my code, take a subarray a is equal to -3, 5. Okay. Now what I'll do is, what this problem is asking is, if we choose 5 as a pivot element, what we need to do is, we need to get the absolute value of it, everything, and subtract the pivot. That is -3 absolute value minus 5. This is gonna give me minus 2. Is that correct? So how my code is gonna work now? First it will calculate the how code works. Code works. So first it will give me the normal sum. Minus 3 plus 5 is equal to 2. Now this 2 should be minus 2 for me now. The correct answer. How do I do this? To do this, we create W from two parts. That is first, second. The first is prefix boost. Prefix boost. And the second one is pivot penalty. Pivot penalty. So in prefix boost, so I have taken prefix boost as P in my code and pivot as U in my code, and W is the correction value. What does the prefix boost do here? We have minus 3. It magically turns, basically it turns minus 3 to plus 3. So inside the running sum, what will this happen? Minus 3 plus 6, this is gonna give me plus 3 inside the running sum. Now what did P become? P is equal to plus 6. Now what is my pivot penalty? Second one is pivot penalty. Pivot penalty is denoted by U. We have 5 that is currently being added. So now to make it basically to make it subtracted instead, what I'll do is I'll apply a penalty of 10. That is plus 5 minus 10 is gonna give me minus 5. So my U is gonna be 10. That is all we are doing. Now we'll calculate our W. W is equal to P minus U. W is equal to 6 minus 10 is equal to minus 4. Now my final result, the final step here, what I'll do is my normal sum plus my correction value. I'll add these two. 2 plus minus 4. What is my answer now? Minus 2. What was the answer I should get when I do it mathematically addition, like manually if I add it? What should I be getting? This is manual calculation. This is code working. This is how the code works. This is the manual calculation. Below this is how the code works. So basically with this we are gonna end today's live stream. If anyone has any doubts, you guys can let me know. Akshay got pressed, I think. It happens. I hope it was a good stream. Sorry for the internet issues in the middle. Any doubts, guys? Any question? Any doubts? Quick. 2 seconds before I end the stream. Can you go Uh, sure, but I'm gonna hide my screen if you want me to look. Okay. Okay, fine. First, let me just show you my screen for the code. Here is the code. I mean, it's go to my profile and you guys can check my code. History, right? Your profile. Give me a second then. Uh, holy moly. Okay. I like your consistency, man. I don't have that graph of code. Fine. Let me just open it here then. Okay. Is it okay if I open your profile on stream? Akshay. Can I open your stream on, like, can I open your account online, like your profile online? Can I do it? Yeah, sure. I appreciate your consistency, man. Like, being this consistent is good, really good. 595 problems, 41 problems last month. So here you have your answer. You have solved 200, almost what, 200 here. Another combined, this is 300. Almost you have solved 500 questions of rating 1100. Okay, and if I include till 1200, almost all the questions you have solved is still that. And what is your peak rating? It is almost 1100. So start solving questions that are above 1300 or 1400. But your consistency is really good. And start practicing the difficult questions. 1300, 1400 questions. And I guess you can push yourself to 1500 or 60. 1500 you can definitely push. Try solving questions up to 1500 level. You can solve it, I guess. Try 1400, 1500 questions. Sure, it's already tomorrow. It's 12:04. It's fine, man. Well, okay, the frame drops. Yeah, it's fine. So thanks everyone whoever joined the stream, guys. Everyone whoever joined the stream, thank you. With this, we are gonna end today's stream. Bye, guys. Have a good sleep and all. Will meet. Probably, I don't know if I should be streaming lead code or not. Let me know if you guys want me to stream lead code. I won't solve lead code. I'll just have to come to explain for you guys. that's all from my side. If you want me to solve lead code, just put a comment in this. I'll come on Saturday or Sunday. I don't know when it's. If bi-weekly is there or not, I don't know. If it's there, I'll stream both together or something, whatever.